Okay, so now we're going to take what we know about moles and apply it to what if we were given grams instead of moles? How do we solve our equations? So what we're going to do is we just have to convert from grams to moles first before we can do anything. So you can kind of think about our mole island that we talked about before. When we're converting to something, we always have to convert to moles first. But if we want to convert then from some sort of molecule, like say we have our reaction here, and we're wanting to convert from oxygen to water, if we're converting from one molecule type to another molecule type, we have to go through moles of that molecule. So you can kind of think about just having another cluster of islands over here. And the only way to get from one cluster to the other cluster is by taking like a helicopter to get from one mole to the other mole. So if I give you, say our molecule A is our hydrogen, and our molecule B is our water, and it could be whichever one, just whatever we're starting with and whatever we're ending with, but we are starting with a different molecule. Say we are starting with moles of hydrogen and we're wanting moles of water. This is the types of problems we've already done before where we can go straight from our moles to our moles. But what if I give you grams of hydrogen instead and I still want moles of water? So you can still convert there. You just first have to convert our grams to moles, and then you can convert over to moles. If I give you grams of hydrogen and I want grams of water, then you can go to moles of hydrogen, then moles of water, then grams of water. So you see how the only way to get from one type of molecule to another is by converting to moles first. Same would go with our atoms or liters. We would convert if we want atoms and we're wanting to end in liters of H2O, we would go atoms to moles of hydrogen, moles to moles, and then moles to liters. So if you get confused, it's always good to just first draw the path that you're going to be following so that you don't get confused. So let's practice drawing the path for problems like this. So say I'm giving you moles of molecule A and I want moles of molecule B. So if we go back over here, we are starting with moles of A and we're ending with moles of B. So we can go straight there. So that means that we're going to go straight from mole A to mole B. So we just have a one-step problem for this one. What if I give you moles of A and then I want grams of molecule B? So what you do in this case, instead of, we're starting with moles, but in the end for molecule B, I want grams. So that means first we have to go mole to mole, and then we can go mole to gram. So we can write that we're going from mole A to moles of B to then grams of B. Okay, this next one, what if I give you grams of A and I want moles of B? So this time we're starting in grams of A and we're wanting to end in moles of B. So here we have to first go to moles of A and then we can go over to moles of B. So our path would be grams of A to moles of A to moles of B. So both of these last two problems that we just talked about are two-step problems. And then another type we can have is when we have grams of A going to grams of B. So even though these are starting with the same unit, grams and grams, our molecule A and our molecule B have different molar masses, which means that their densities are going to be different. So that's going to affect how much is being produced. So we cannot go straight from grams to grams. We have to first go to moles and then moles of the other thing and then over to grams. So this is going to be our three-step problems where we start with grams of A, we then go to moles of A so that we can convert to moles of B, and then we can convert that into grams of B. So those are probably the most difficult ones where we have those multiple, in this case, 3 conversion steps. Okay, so this is a practice problem. The equation's already balanced for you. We have 12.00 moles of NaClO3 will produce how many grams of O2? So we can first write out our path that we're going to follow. So we're starting in moles of this, and eventually we want to get to grams of O2. But we cannot go straight from moles of one thing to grams of another thing. We first have to go to moles of whatever we're going to, and then we can go to grams of the last one. So this is the path we're going to follow. So we're going to start with our number that we're given, moles of sodium chlorate. Okay, and then we can draw our chart. The first thing we're going to do is go to moles of oxygen. So that means we need to cancel our moles. So that's going to put our moles down here on the bottom. And we're going to moles of oxygen. And whenever we have moles over something, moles of one thing over moles of another thing, we're going to use our balanced chemical equation and our coefficients. So we look for NaClO3, we see that there's a 2, so the 2 is going to go down here. We look over at our oxygen, it has a 3, so our 3 is going to go up here. So now we can cancel our moles of NaClO3, and we are now in moles of O2, which is what we wanted. We just did this part of the step. So now we need to convert to grams of O2. So that means we're going to put moles of O2 on the bottom so that it can cancel. And then we're going to put grams of O2 on the top. And whenever we have grams of something over moles of the same thing, or if you could have it the other way, we have moles of O2 over grams of O2. Whenever you have grams and moles, you're going to use the molar mass. So if you remember what we do for our molar mass, we have to look at our periodic table. We have to look at oxygen right here. Oxygen has a mass of 15.999. Oops. And we have 2 of them. So 15.999 times our 2 oxygens give us the molar mass for oxygen is 31.998. And so I'll write that up here. And that's in grams per mole. Okay, so this number is going to go with our grams. This is saying 31.998 grams per 1 mole of O2. So we will put 31.998 grams of O2 per 1 mole of oxygen. So now our moles of O2 cancel, and we're left with grams of O2, which is what we want. So to do this calculation, we're going to do 12.00 times 3 divided by 2 times 31.998. And remember, we have to use our right number of sig figs, so we would use this number that we're given here, 12.00. That has 4 sig figs, so we're going to write 5, 7, let's see, we need 4 sig figs. Let me just write this number down, 575.964. And then our unit is grams of O2. But we only want 4 sig figs, so if you notice 1, 2, 3, 4, but this 6 behind that 9 is going to round this up. So it's actually going to be 476.0 grams of O2. So this is how we solve these problems. So try this one. If you want to pause the video, you can try it on your own. It's already balanced for you. Okay, so this one you're starting with 0.234 moles of silver nitrate. And we're wanting how many grams of silver are going to be produced. So we're starting with moles of silver nitrate, so we can draw our path, and eventually we want grams of silver. And we can't go straight there. We have to first go to moles of silver, and then we can go to grams of silver. Let me change. Oh, no, it's fine. Okay, so now we can set up our chart. We're going to put moles of silver nitrate, and the first thing we're going to convert to is moles of silver. We have moles over moles of something. We're going to use our equation. We see that in front of our silver nitrate we have 2. In front of our silver we also have a 2. Okay, and then now we're in moles of silver. We want to cancel that, so we'll put moles of silver on the bottom, and we're going to grams of silver, so that's going to go on top. And if we have grams over moles or moles over grams, we're going to use our molar mass. So we go back to our periodic table. We see silver is 107.87 grams per mole. So it's going to go up here. And then we have 1 mole of silver on the bottom. Okay, so this unit cancels with this unit cancels with this unit. So what we're going to do is we're going to do 0.234 times 2 divided by 2 times 107.87. And we're going to use 3 sig figs, so we will write 25.2 grams of silver. And you may have noticed that since it's 2 and 2 for a molar ratio, it actually ended up being that these cancel out. And so if you see that and notice it and want to kind of skip that step, you're welcome to. But I always try to do it just in case so that we don't get confused and mess up something. Okay, so now we have our next problem. So first you have to balance this one though. Let's take a second and try to balance this one. So I'm actually going to copy it over to another page so we can balance it so I have more space. So we have AU and we have CL. So right now we have 1 on the left, we have 1 on the right, but our chlorines are what's messed up. We have 3 chlorines and 2 chlorines. So what we can try right away is we can try multiplying this side by 3 and multiplying this side by 2, because that will give us 6 chlorines on both sides. So that means this 3 is going to go in front of our chlorine here, and that is the only thing that affects. This 2 is going to go up here, and that also affects you over here. So now we need to fix that by adding multiplying by 2 on the right side so that we have a 2 here as well. And then we're all balanced. So 2, 2, 3 is our coefficients. It's always good to double check to make sure your chemical equations are balanced, because that can really mess you up pretty easily if it's not balanced. And you can always just go and double check everything. AU, we have 2 on this side, 2 on this side, 2 times 3, 6 chlorine, 3 times 2, 6 chlorine on that side. Okay, so in this question, it wants how many moles of chlorine can be liberated, which is just saying how many can be produced from the decomposition of 64.0 grams of AuCl3. So in this one, we are given grams of AuCl3, and we're wanting to eventually get to moles of chlorine. And we cannot go straight from grams of one thing to moles of a different thing. We first have to go to moles of AuCl3, and then we can go to moles of Cl2. Okay, so that's when we're starting with 64.0 grams of AuCl3. We're then wanting our grams of AuCl3 to cancel, and we want to have moles of AuCl3 on the top. If we have grams and moles over each other, we're going to use the molar mass. So that means we need to look at the molar mass of AuCl3. So let's go back to our periodic table. Gold's molar mass is 196. Let me pull that up. 196.97 plus parentheses because we have 3 chlorine and its molar mass is 35.45. So our molar mass is going to be 303.32 grams per mole. Okay, so that means this number is going to go on the bottom. And then we have 1 mole of gold on top. Okay, so our grams of AuCl3 cancel. We're left with moles. Now we need to go from moles of AuCl3 to moles of chlorine. Moles over moles, we're going to use our equation. So we look up here, we have a 2, and then in front of our chlorine we have a 3. So each of these cancel, and we're left with moles of chlorine. So for our answer for this, we will do 64.0 divided by 303.32. Oops. Times 3 divided by 2 is this number. We'll have 3 sig figs because it has 3 digits, so it will be 0.316. And our unit is moles of Cl2. That's our final answer. Okay, so we can try this next one where we're wanting how many moles of gold can be produced from 54.2 grams of silver chloride or gold chloride. I'm going to just copy this down here so that we have it, so it's easier to see. Okay, so in this one, we're given grams of gold chloride again, and we're wanting to get to moles. We can't go from grams of one thing to moles of a different thing, so we first have to go to moles okay, and then we can go to moles of our other thing. So we are starting with 55.2 grams of AuCl3. And the first thing we need to do is convert that into moles. So that means we're going to put grams on the bottom. And we're going to put moles on the top. Whenever we have grams over moles, we're going to use our molar mass. And if you remember before, we actually already calculated our molar mass of that. It's 303.32 grams per mole. So that's going to go down here. per our 1 mole. These two things cancel. We're now in moles, and we need to convert to our moles of gold. So that means to cancel, we need to put our moles of gold chloride down here and our moles of gold on top. Moles over moles, we're going to look at our balanced chemical equation. So our moles of gold chloride are 2, and our moles of gold are also 2. So if you notice that it's going to be the same thing, 2 over 2 cancel, you could skip that step if you want. I'm going to write it anyway, though. Okay, so we will do 55.2 divided by our molar mass, which is 303.32, and then times 2 divided by 2. It's going to give you this. And we have 3 sig figs, so we're going to write 0.182 moles of gold. And that's our final answer for that one. Okay, so if you were not here for class, here's the ticket out the door that you missed. Make sure that you use the correct units and sig figs.